Do you have any doubt, or should I start like my questions, whatever I have to ask? Yes.
सो आप इस लीनियर अलजेब्रा के टॉपिक्स में मतलब आप ये सब बता सकते हैं कि कौन सा टॉपिक इजी है, कौन से टॉपिक्स इजी है, कौन से मॉडरेट है, कौन से टफ, मतलब आप समझ गए ना सर, सरल माध्यम से।
There is no conclusion like this.
नहीं
कोई भी
कंक्लूड
टॉपिक सुनो, कोई भी टॉपिक टफ कुछ नहीं, मैं आपको बताऊं। जैसा मैंने
सब
बताया, कंप्लीट कीजिए, उसमें कुछ भी टफ नहीं है, कोई भी इजी नहीं है, कोई भी टफ नहीं है। इफ यू डू नॉट नो द कंसेप्ट, then that is tough. If you know the concept, that is easy. Every topic in linear algebra.
ओके सर।
मुझे ये बता दो कि टफ का मीनिंग क्या है?
टफ सर, टफ मतलब वो नहीं कंसेप्ट, अगर आप जैसे मुझे आइगन वैल्यूज आइगन वेक्टर आ गए, मुझे मतलब नॉर्मल जैसे सिस्टम ऑफ लीनियर इक्वेशंस, आइगन वैल्यूज आइगन वेक्टर और केली हैमिल्टन, ये सब टॉपिक्स कर सकता हूँ। लेकिन मतलब कुछ एक वो डायमेंशन वाले जो मैंने पिछली बार उन्हें किए थे, लेकिन इस बार
देखिए ऐसा है, तो डायमेंशन वो कुछ भी जो पेपर है, दैट इज डिफिकल्ट और इजी फॉर यू, नॉट फॉर एवरीबॉडी। अंडरस्टैंड? सो I cannot say कि this is tough, this is easy. So don't be confused. Whatever we have done in the class, the recorded class, and whatever we are doing, you just focus on all these things, nothing else. ठीक है? Today is 1st February, today is Tuesday, and the Sunday, the next Sunday you have a paper. So अभी बिल्कुल भी confuse नहीं होने का है, बिल्कुल भी, because this is the crucial time, and if you confuse right now, then it will be very difficult to like understand the paper. अगर अभी से आपने difficult और ये चीज सोचा, कुछ मत सोचिए, जितना करा है उतना ही कर लीजिए, ठीक है? यस, डन। नाउ किसी की कोई भी डाउट है, whatever doubt if you have, you can tell me right now, otherwise I am going to start my session. चलिए, so I have some good questions, so you can solve that question. I will give you the solution of that question also. Let A be n cross n real matrix with A square is equal to A. Then option number A, eigen value of A are either 0 or 1. A is diagonal matrix with diagonal entries zero or 1. Rank of A is equal to trace of A. D is rank of A minus I is equal to trace of I minus I. Yes. Which of the following is are true? It means this question is MSQ question. You have to think and give me answer properly.
सर ABC आंसर
ABC. Okay, what about others? A, B, C. One is saying AC. See, A is idempotent matrix.
नहीं.
This is clear कि A is idempotent matrix. Yes or no? A is idempotent matrix. Idempotent matrix has eigenvalue 0 or 1. This is okay. A is diagonal matrix with diagonal into 0 or 1. The A is idempotent, then A is diagonal only. Yes. So I think this is wrong answer option now. A is diagonal matrix. Okay, diagonal then idempotent, okay. But idempotent then diagonal. It means all of the idempotent matrix are diagonal with the entry 0, 1 in the diagonal. No. Is it clear? Rank of A is equal to trace of A, you know. Rank of A is equal to trace of A. You know this one. So most probably, most of you will write down the answer A and C. What about D? This is correct or wrong? Because we don't know about that one. Yes. What is the answer of this? Yes.
Actually, sir, seems like D is also true because I minus A is also idempotent.
Okay, I minus A is idempotent. मैंने मान ली बात. Okay. I minus A is idempotent. Then
And idempotent matrix के लिए वैसे rank और trace equal होता है.
okay, so rank of I minus A is equal to trace of I minus A.
And the rank of I minus A बोलो या A minus I think same होना चाहिए.
Why?
Elementary operation.
Yes, this is called the elementary row operations because you are taking common as -1 na, -1 in the matrix. So what you are doing, I minus A and A minus I, you are multiplying each row by -1. It means this is the elementary row operation, does not change the rank of a matrix. So it means this option is also correct. Am I clear? So the answer is A, C and D. No, chaliye. So next question. Next question is yesterday question which we have discussed yesterday. The yesterday question is like yesterday we have taken one matrix like A theta, and A theta is cos theta minus sin theta and cos theta, and we are taking theta belongs to 0 to 2 pi. So question is, A theta has real eigenvalues. A theta has real eigenvalues. A theta has these number of A theta has real eigenvalues for exactly this many values of theta. Yes. A theta has this much eigenvalues of exactly
0 पर open है sir.
0 open and 2 pi close.
ठीक.
So time sufficient time you can take around 2.5 minutes. So don't be in hurry कि मैंने आपको जल्दी से आपको फटाफट आंसर बताना है. No, the answer must be right. If you take 3.5 minutes, that is not a problem. Pi and 2 pi. So Pratiksha, how did you find out the answer? If you have find out this answer, I don't know what is the answer. Answer is correct or not, but how did you find out the answer? Pratiksha, can you speak over the mic? So any other student who want to speak, or the eigenvalues are e raised to power plus minus I theta. How can you say?
Sir, plus minus 1.
Plus minus 1 means eigenvalues are plus minus 1. But I am not asking, I am asking the A theta has real eigenvalues for exactly how many values of theta? One value of theta, two value of theta, infinitely many value of theta, uncountable many values of theta. What are the number of values of theta? So that, so two
Two
values.
values.
So how did you find out the answer?
Sir, because there are only two real eigenvalues plus minus 1, and we find that only pi, when we put theta on
Do
pi.
you have a solid background of like how to create? No, cos theta
Hello,
plus minus sin theta is the eigenvalue.
sir.
Yes.
अगर हम गिवन मैट्रिक्स का वो निकालें, आप क्या बोलते हैं उसको, characteristics polynomial, then we will get lambda square minus 2 cos theta lambda plus 1 equal to 0.
Lambda square minus trace of
Yeah, 2 cos
a
theta
into this
lambda.
plus determinant of a is equal to 0. So lambda square minus twice cos theta lambda plus 1 equal to 0.
अगर हम वो क्वाड्रेटिक वाला फॉर्मूला लगाएं तो हमारे पास लैम्डा की वैल्यू माइनस बी प्लस माइनस होता है ना सर फॉर्मूला.
चलिए ठीक है, मतलब अप्रोच इज राइट, बट आई वांट टू टेल यू कि इसके बाद आप रूट निकाल ही क्यों रहे हो? आपको पता है डिस्क्रिमिनेंट b square minus 4ac must be greater
Should be.
than 0 for real eigenvalues. For real eigenvalues. So what is b? B is here b equal to I think 2 cos theta minus k. Okay, and a equal to 1 and c equal to 1. So b square means 4 cos square theta minus 4 into 1 is greater than equal to 0. So you must write down greater than equal to 0. Okay, you must write down greater than equal to 0, not greater than 0 only. Okay, because equal to 0 equal root, that is also real. So here you can write down cos square theta minus 1 is greater than equal to 0. Is it possible? So we have two cases here. One is cos square theta minus 1 is greater than 0. One is cos square theta minus 1 is equal to 0. This is not possible. This is possible. This is possible. Cos square theta is plus minus 1. Sorry, cos theta is plus minus 1. So cos theta is plus minus 1. So what is the like graph? Graph is like 0 to 2 pi this graph, and you are saying okay, this is 0 plus minus 1. This is 1 point. This is also second point, and this is a third point. Okay, these are the points only. Then so this is not included, this is included, and this is included. It means theta is equal to pi and theta is equal to 2 pi. You have two eigenvalues which are real. And what are the eigenvalues? You can find out the eigenvalues by that one. Is it clear?
Clear, sir.
Okay, this kind of problem you can find out directly. Like this approach is, I think, absolutely clear. And Tanu, you are saying this has cos theta plus minus sin theta eigenvalues here.
Actually,
Right?
sir.
So you can find out by the help of like this, na? Yes. Yes. But one more thing I want to tell you: if there is a problem, you can change the problem. If you write down here minus, so answer will be same. But you can
Yes,
change,
sir.
if problem will be changed, then your answer will be changed. So you have like you know the answer cos theta plus minus sin theta, but if the problem is changed, minus cos square theta minus sin square theta, the determinant is minus 1. So there are so many possibilities of the questions, so you can create as many as question and you can give the answer easily. Yes, any doubt? Yes.
नो डाउट सर, बढ़िया क्वेश्चन था.
ठीक है ना, you can find out. And let us consider you know symmetric matrix has real eigenvalues, you know, but skew symmetric matrix has complex eigenvalues. Maybe you know, skew symmetric matrix has either eigenvalue 0 or purely imaginary. So I am giving you one question of the skew symmetric matrix also, like that. This is skew symmetric matrix, and we are saying theta belongs to 0 to 2 pi. So can you tell me how many value of theta the eigenvalues are real? The same thing, the lambda square. This is the same technique, minus 0 into lambda. 0 minus that is sine square theta, I think, na? That is 0 minus plus sine square theta. So this is the characteristic equation. So lambda square plus sine square theta is equal to 0. This is the characteristic equation of this skew symmetric matrix of order 2 by 2. So what are the eigenvalues? So what are the value of theta so that the values eigenvalues, real eigenvalues?
सर रियल आइगन वैल्यूज निकालनी है क्या?
Yes, yes, yes.
रियल तो नहीं निकलेंगे सर इसके लिए.
Real नहीं निकलेगी. Yes, very good. Any other student?
Because lambda is equal to plus minus iota sin theta. It's
Very good. Any other want to say anything?
Only complex eigenvalues.
Only complex eigenvalues. Who said this? Your name?
Actually sir जीरो पर निकल जाएगा सर. जीरो पर sin theta जीरो. Yeah.
This is the panga. You know the complex, the skew symmetric matrix has real eigenvalues when lambda is equal to 0 only.
Yes.
Basically, skew symmetric matrix are real eigenvalues, only 0 real eigenvalues. Otherwise, purely imaginary. तो 0 eigenvalue होगी तो आप डाल लो lambda की value 0. So when you put lambda is equal to 0, the only possibility of theta, if exists, then you can say that will give the 0 eigenvalue, otherwise not. So sin theta is 0. So sin theta is 0, then theta is equal to, you can find out what.
Even 2 pi पे भी निकल सकता है ना सर?
0, pi by 2, pi, 3 pi by 2 and 2 pi. Yes or no?
सर pi by 2 पे तो sin theta 0 नहीं होता ना?
Sorry. मैंने कुछ गलत बोल दिया. Sorry.
It's okay. Pi and 2 pi तीन चीजें हो सकती है.
But whenever we see this problem, we just directly write down what we will write down. We will directly see no, there does not exist any real eigenvalues because lambda square plus sin square theta, lambda square minus sin square theta. हम डायरेक्ट यही सोचते हैं lambda square is equal to minus sin square theta. How it is possible? Sin square theta is positive, so there does not exist directly. Okay, but your answer is wrong.
थोड़ा पेशेंस होना चाहिए सर शायद, है ना?
So मैं इसलिए कहा था don't be worried about time. The time is 3 minutes for you, and if you know कि you can give the answer correctly, so take 1 more minute or half more minute, so that no हड़बड़ी, no जल्दबाजी, आपका आंसर सही होना चाहिए. This is the main priority. And one more thing I want to tell you, whenever you are going to give the exam, there are a lot of questions which are very easy, but easy questions are in the boundary of the tough questions. Okay, some IITs, what some IITs do, generally do the tough question, there is easy question, then tough question, tough, easy, tough, easy, tough, easy, tough. So this kind of pattern will be there. So if you have to filter, so if you filter the questions, basically 50 to 55% of questions are easy category in IIT exam or every paper. 50 to 55%. If you have patience, okay, and you can find out, you can filter out all the problems which are easy in first round. Basically, you have to give 2 rounds of the paper. First of all, start the paper. Do not read all the papers. First of all, I want to understand what is the paper. You are not doing any kind of research. You are going to appear in a paper. Okay, don't read full paper. Otherwise, you will be completely confused. Okay, in the paper hall. So what you have to do, start from question number 1, do whatever question you are not going to solve, okay, no problem. So do as much as possible questions and take time around 2 to 3 minutes or 3.5 minutes maximum. So give this time, and if problem is not solved, leave it. If you are seeing some problem which are looking very difficult and you are saying, oh, mere bas ki baat nahi, I cannot solve, so leave it. So in the first round, in this way, you can secure 50 to 55% marks, and which is absolutely correct. Like 90% of accuracy will be there, until unless you are doing some calculation mistake. Okay, 55% marks. In the second round, please be patient. More patience you should have. Okay, and you can crack around 15 marks correctly out of them. And remaining portion, if the question is MCQ, leave it. If MSQ and NAT, you have to write down the answer without no negative marking. So this is the second round. Okay. So in this way, you can easily secure 70 marks. मेरे हिसाब से मतलब easily 70 marks is easy in this pattern. If you have complete knowledge of subject which is under IIT. जैसे मेरा linear algebra, integral calculus, मैं अपनी भी बात कर रहा हूँ, ठीक है? So in this you can do. Done? चलिए.
So then about this question, we say that there are 3 points of real eigenvalues and 2 points of imaginary.
No, not 2 points. Only in this interval at 3 values of theta, 3 distinct values of theta, the eigenvalues are real and the eigenvalues are 0, 0. Otherwise, uncountable many points of theta. For the uncountable many points of theta, A has complex eigenvalues and the eigenvalues are purely imaginary. Yes or
Okay,
no?
sir.
Because the skew symmetric matrix either has 0 eigenvalue or purely imaginary. Is it?
Yes, sir.
Let A be 3 cross 3 matrix with real entries, then A is necessarily diagonalizable over R. If A has distinct real eigenvalues, then A is diagonalizable over R. If A has distinct eigenvalues, then it is diagonalizable over C if all eigenvalues of A are non-zero, then it is diagonalizable over C.
Sir, is it MCQ or MSQ?
So you can treat every question in today's class is MSQ.
Okay.
Yes, every question is MSQ for this class.
Sir, MSQ में अगर जैसे 3 में से हमारा एक ऑप्शन करेक्ट है लेकिन हमने 2 सेलेक्ट नहीं किया है, तो हमें क्या मार्क्स मिलेंगे कि
देखो जितने करेक्ट हैं उतने ही आंसर तुमने लगा दिए तो मार्क्स मिलेंगे पूरे, अदरवाइज मिलेंगे 0. मतलब 3 में से तुमने 1 लगा दिया और आंसर है 2, तो आंसर में मार्क्स मिलेंगे 0. Done? So correct answer is BC.
Sir, not done. Just
Okay. This is BC. See, A is necessarily diagonalizable over R. It means every matrix of 3 cross 3 matrix of real entries are diagonalizable. How can you say? If A has 3 distinct real eigenvalues, the matrix is diagonalizable over R. Yes, because R के ऊपर ही diagonalizable है. Because you are taking the matrix from the real entries. Real entries matrix may be diagonalizable over R or may be diagonalizable over C. If you have 3 distinct eigenvalues and it is not given the eigenvalues are real, so that is always diagonalizable over C but not R. Yes, but in this question it is given that this matrix has 3 distinct eigenvalues. If a matrix has 3 distinct eigenvalues which are real, then diagonalization over R is compulsory. And third is, if a matrix has distinct eigenvalues but it is not given this is real or complex, so always complex to the diagonalizable होगी, and if real then real पे भी हो जाएगी. So this is also correct. Yes. If all eigenvalues are non-zero, then it is diagonalizable over C. No. So B and C are the correct option. Am I correct? Done. Next problem. Let M and R is n cross n real matrix, set of n cross n real matrix over the field R. Then n greater than 2 के लिए statement. There exist matrices AB belongs to M and R such that AB minus BA is IN. If A comma B belongs to M and R and AB is equal to BA, then A is diagonalizable over R if and only if B is diagonalizable over R. C is if A and B belongs to M and R, then AB and BA has same minimal polynomial. And D, if AB belongs to M and R, then AB and BA has same eigenvalues in R. Please take some time. B, C, D. हाँ चलिए चलो मैं एक्सप्लेन करता हूँ. There exists a matrix AB belongs to M and R such that AB minus B is IN. This is a very famous question. You know this is a wrong statement. There does not exist this kind of matrix because for option A, AB minus BA is IN. Let us consider, and if you take trace both side, that must be equal. So trace of AB minus BA is trace of AB minus trace of BA. That is IN, that is equal to N. So that is 0, that is equal to N. It implies, which is absurd. Which is absurd. N equal to 0, that does not pass possible because the matrix of order 0 order is not defined. At least one order is defined matrix. So this is absurd. Very good. This is wrong options. The second option is if A and B belongs to M and R. A and B belongs to M and R. And AB is equal to BA. Then A is diagonalizable over R. If and only B is diagonalizable over R. How can you say AB is equal to BA? AB is equal to BA. Two matrices commute. Okay. B diagonalizable over R, then A diagonalizable over R. If A diagonalizable over R, then B is also diagonalizable over R. Can you say like this? See, see, if similar matrix you can say, can you say AB and BA? It means AB and B are similar matrix. Are you thinking AB and B are similar matrix? Tell me. Are you thinking this way कि AB and B are similar matrix? Yes. How can you say AB and B are similar matrix? So how can you say AB and B are similar? Option number B is AB and BA are similar. If AB and BA are similar, then you have to write down AB is equal to BA and there is some P inverse AP. So what you will write down? Let us consider AB is similar to BA like that, and AB, and this is the equivalent solution that is you know already. But AB is equal to P inverse AP. So how to write down the P inverse? Actually, I think you must write down here B inverse P. Yes or no? Yes or no? But if B is not similar, how can you say? If B is not similar, is it clear? Am I clear? Without invertible matrix B, how can you say that AB is similar to BA? Am I correct? Because you have to write down. Huh?
बिल्कुल करेक्ट है सर आप.
Otherwise, you cannot write down any matrix like that. Any other student want to say anything? And second one is, okay, this is the matrix B inverse AB, that is AB. Okay. And BA is equal to, you can write down AB and BA are similar. So AB, okay, B inverse. Okay. It means at least one matrix must be similar, non-similar. Either you can say A or you can say B. Otherwise, we can write down also. If B is non-singular, then AB is similar to BA. Yes. Let us consider A is non-singular. A is non-singular. We can write down A inverse A. Yes or no? So either it means similar बनाने के लिए मुझे ऐसा लगता है कि एटलीस्ट एक मैट्रिक्स आपको नॉन सिंगुलर लेनी ही पड़ेगी. Yes or no? Yes. So going back.
सर
Yes.
आपको ऐसा नहीं लगता अगर दोनों ही नॉन सिंगल होंगी तो ओके नहीं है.
अगर दोनों नॉन सिंगुलर होंगे तो कोई दिक्कत ही नहीं है. Am I clear?
यस सर.
अगर तुम ये कहते हो कि ए बी सिंगुलर बी ए की जब भी हो सकती है जो दोनों नॉन सिंगुलर होंगे, so you are saying the non-singular matrix are only this kind of matrix such that AB is also similar, but similar matrix can be similar matrix. Okay, so this point is I think clear, but question is not clear. So going back, if ABC AB belongs to MNR such that AB is equal to BA, AB is equal to BA, okay, then A is diagonalizable over R if and only if B is diagonalizable over R. This is correct or wrong? See, if B is diagonalizable over R, हो सकता है कि AB and BA both are non-singular, so singular, both are singular. Okay, मैं दोनों का जो है like you can say कि one is diagonalizable but the other is not. Can you give me an example? I am saying option B is wrong. You are saying option B is correct. So whoever write down the option B is correct, can you prove me कि B is correct?
Sir, let me do it.
Yes.
क्वेश्चन कह रहा है सर कि A is diagonalizable over R if and only if B is diagonalizable. यानी इसका मतलब उसने पहले से ही बोल दिया है कि B diagonal है तभी A होगा, और अगर B diagonalizable है तो पक्का B तो नॉन जीरो होना चाहिए, सॉरी लाइक नॉन सिंगुलर होना चाहिए.
किसने कहा? B diagonalizable it means non-singular. There is no guarantee. Diagonalizable matrix may be that like a matrix is diagonalizable but that is singular. 1 0. See, the question is saying कि AB is equal to BA. That is okay. A is diagonalizable over R if and only B is diagonalizable over R. Can I give some examples? B is identity matrix. Is it क्या ये example काम करेगा? Like let A is equal to B A. A is equal to B A. Yes or no? A B is equal to B A. Yes or no? A B is equal to B A. Yes or no? Whatever I am asking, just say yes or no. This is identity matrix. B is diagonalizable, but A not. Why? Because A is nilpotent matrix, and nilpotent matrix cannot be diagonalizable. Nilpotent matrix cannot be diagonalizable. If not, this is diagonalizable if and only if A is 0 only. This is not given. This is a similar matrix. It is not given. This is similar matrix. Okay. This matrix AB is equal to BA does not mean that we are under the process of similar matrix. Okay. AB is equal to BA. You are multiplying a matrix. Pre and post both are same. That matrix are commute. So A and B are diagonalizable. A diagonalizable. B diagonalizable. A no. This is the one of the wonderful concept. This is a nilpotent matrix. Yes or no? Is it clear? So option number B is also wrong. Option number C, A and B belongs to M and R. See देखो ऐसा है कि like मेरे हिसाब से ना क्वेश्चन कोई भी करा सकता है ये. This question can be explained. But whatever I am saying line by line. Each and everything is interlinked. See, मुझे पता है कि मुझे कितना पता है. I know कि how much I know the things. I am not perfect. Even just thing is कि everybody can solve the problem. Everybody can teach the problem also. But whatever I am saying, the point, please note down for the IIT exam 2022. These are the points which can, if you connect all these points, you can easily do most of the question in IIT exam 2022 from my topics. This is like as I know कि अगर आप सही से कनेक्ट कर लोगे ना चीजों को तो वो सारी चीजें आप कर पाओगे एग्जाम में. क्योंकि मेरा my aim is not only solving the problems. I want to skill you so that you can solve your problems. Your problems is IIT exam 2022 problems, not now. Yes. If A and B belongs to M and R, AB and BA has same minimal polynomial. So AB belongs to M and R, then AB and BA has same minimal polynomial. Acha, tell me one thing. Before solving this problem, I am just asking you, if AB and BA has same characteristic polynomial. Without solving this problem, my question is the question number C. C question is if A and B belongs to M and R.
Sir,
एक मिनट. AB and BA has same characteristic polynomial. Yes, बताइए.
मैं ये सोच रहा था सर, अगर ए बी अगर मान लीजिए निलपोटेंट ही आ जाता है ए बी कोई दो मैट्रिक्स के लिए, तो कैरेक्टरिस्टिक्स पॉलिनोमियल तो एग्जिस्ट ही नहीं करेंगी उसके लिए, तो शायद, है ना सर?
Nilpotent matrix of characteristic polynomial is lambda raised to power n because all the eigenvalues are 0.
हाँ, तो बिकॉज लाइक सारी की सारी आइगन वैल्यूज 0 होती हैं. ए बी जो है हो सकता है निलपोटेंट आ सकता है एंड बी ए नॉट निलपोटेंट आ सकता है. हम एक ऐसी मैट्रिक्स ले भी तो सकते हैं ना सर?
ले लो, मुझे नहीं पता, बताइए क्या मैट्रिक्स
तो
है। AB and BA has same characteristic polynomial. Yes. Who will speak? This is right or wrong? Thanu is saying right and Manoj saying no. The AB not equal to BA. So AB is equal to BA. If AB equal to BA, then characteristic polynomial are same. Yes, because AB both matrix. If two matrices are same, then characteristic polynomial is also same. Yes or no? AB and BA have same characteristic polynomial. Acha, can you tell me one thing? AB and BA. AB is equal to 0, but BA is not 0.
not possible, sir. Not possible.
AB, not possible.
Yes, sir. Because sorry, AB determinant दे रख नहीं, determinant नहीं है ना. Sorry, sir.
AB is equal to 0, but BA not equal to 0.
मुझे लगा कि आपने determinant क्यों कह रहे हो शायद. अगर determinant होता तो फिर ऐसा possible नहीं हो पाता. बाकी ऐसे तो possible है.
Can you give me an example of this?
एक मिनट सर, मैं ढूंढता हूँ.
मैंने क्वेश्चन थोड़ा सा घुमा रहा हूँ चीजों को, so that you can understand in better way. This is मतलब ये क्वेश्चन कुछ अजीब टाइप के होते हैं, अरे IITs में आते हैं. Yes
सर. A को लिख लीजिए आप 0 0 1 0
0 0 1 0
और B को लिख लीजिए 1 0 0 0
1 0 0 0. So AB is 0. AB is this 0, this 0 0. But कहाँ AB कहाँ 0 है?
सर AB 0 नहीं आ रहा, AB 0 नहीं आ रहा, BA 0 आ रहा है. मतलब बात तो लगभग एक ही है ना, मतलब आगे पीछे कर लेंगे तो.
This is AB is not 0, but BA.
नाम चेंज कर देंगे तो आई थिंक वो चीज भी हो जाएगी.
BA is like, okay, this. BA 0. But the problem is, AB and BA has same eigenvalues. See, the case are, if A is invertible, exist, then AB and BA are similar. Yes or no? It means same eigenvalues. Yes or no? If B inverse exists, cases, I am creating cases, then AB and BA are similar. Means same eigenvalue. But the third case is, if A is not invertible, B is not invertible. Okay? If A is not invertible, B is not invertible. Yes. Cases. समझना जरा deeply. If A and B both are singular, then the question is, AB and B are similar. AB and B are similar. Question is, AB and BA are similar. Yes or no? Yes or no? फटाफट बताइए. Yes or no? Confidence. You must have confidence. Whatever you are saying, this is right. Otherwise, you will not attempt more question in IIT exam. So please tell me. AB and BA are similar. Obviously, these are not similar, na? These are not similar. Done. Can you say कि these like AB and BA does not have same eigenvalue? Does not have same eigenvalue. Is it true or false? Yes or no? फटाफट बता दो. Yes or no? No. Why? This is true or false? I am saying whatever statement I have written here, this is true or false? This is true.
सर ए एंड बी जो है सिंगुलर है.
Yes. No, no. Whatever I am saying, all the eigenvalues, Thanu, all the eigenvalues, AB and BA are same eigenvalue, means the set of eigenvalues of AB and BA both are same. This is true or not? Does not have same eigenvalues. This is true or false? See, number one. Similar matrix has same eigenvalue. Similar matrix has same eigenvalue. Yes or no? Similar matrix has same eigenvalues. But if matrix is not similar, can you say the eigenvalue is similar? Eigenvalues are same. The eigenvalues are same. No. See, पहले मेरी बात समझिए. Similar matrix are same. Similar matrix has same eigenvalues. That is okay. If matrix are not similar, so similarity is not the guarantee of same eigenvalues. Similarity is the sufficient condition to prove that the eigenvalues are same. Similarity is not the necessary condition. Student, just understand my point. Similar matrix has same eigenvalues. Similar matrix has same eigenvalues. Similar matrix has same eigenvalues means this is the sufficient condition, not necessary. If the matrix are not similar, maybe that the matrix has same eigenvalues. Maybe. How can you say? You cannot say like that. Yes, you cannot say like that. So it means what I'm trying to say, AB, A in A and B both are similar matrix. So AB and BA both are similar. Yes or no? Yes or no? Yes or no? See what I'm saying. If AB and BA are similar, it implies AB and BA both are similar. Singular. It implies 0 is one of the eigenvalue. One of the eigenvalues of both AB and BA. Okay, so 0 are the same eigenvalues. Yes or no? 0 are the same eigenvalues. Very good. Yes. ठीक है? 0 are the same eigenvalues. So it means we have to prove now. We have to prove or disprove that if AB has lambda not equal to 0 as a non-zero eigenvalue, then BA also has lambda non-zero as an eigenvalue. अगर आपने ये प्रूफ कर दिया, it means you can say AB and BA has same eigenvalues. AB and BA has same eigenvalues. Yes or no? Yes or no? So can you prove that if you take any non-zero eigenvalue of AB, if you take any non-zero eigenvalues of AB, if AB has non-zero eigenvalue, lambda is not equal to 0 and x is not equal to 0, so AB has non-zero eigenvalues. So that is lambda x. Yes or no? So can you prove that? Was my question is very simple. Can you prove that BA also has same eigenvalue lambda? बस मुझे ये प्रूफ कर दो और मैं आपको बता दूं दिस इज द करेक्ट ऑप्शन. दिस इज द करेक्ट ऑप्शन कि AB and BA has same eigenvalues because AB in AB and BA, if A is invertible, similar, B is invertible, similar. If A and B are not invertible, even you can say same eigenvalues, even the matrix is not similar. This is the thing. Yes, I am giving you 1 minute. Please think and tell me how to prove that. मैंने पूरी कहानी बना दी आपके सामने. That is मतलब question. So many student has done rectifications. They have done rectifications for these questions. Every book has the statement कि AB and BA has same eigenvalues, but I can say how. How is not given. See here, time is over. ABX is this, multiply BABX is equal to B lambda x, BA of BX lambda BX. So I am saying BA of BX equal to lambda times of BX. So BA has eigenvalue lambda with eigenvector BX. And BX, it means BX is non-zero. BX, you must prove that BX is non-zero. Otherwise, x equal to BX must be non-zero. Why BX must be non-zero? We have to prove this one. Why? Because A of BX equal to lambda x. If BX is 0, then A into 0 is equal to lambda into x. A into 0 is 0, lambda x. Or lambda x equal to 0 and x is non-zero, it means lambda is equal to 0. But what we have taken, lambda is non-zero. Lambda is non-zero, it means BX is non-zero. It means BA has eigenvalue lambda and eigenvector BX. मेरी बात समझ रहे हो? Sir, my example failed for non-zero eigenvalue are different. Sir, my example failed for non-zero eigenvalue are different.
Sir,
Yes.
only in the case of eigenvalues are 0, it satisfies. Otherwise, the non-zero eigenvalues are different, sir, according to my examples.
Yes.
Non-zero eigenvalues are different for each cases.
Non-zero eigenvalue can be different.
Yeah, yes, sir.
Can you give me an example?
I took a matrix, 2 cross 2 matrix of
2 cross, wait. 2 cross 2 matrix.
2 1 4 2.
2 1 4 2.
And another matrix B. This is A. B is equal to 1 1 by 2 2 1.
Okay. What do you want to say?
Both the matrices having 0 as the common eigenvalue.
0 as the common eigenvalue.
Yeah.
Okay.
And the non-zero eigenvalues are different.
एक बार निकालना non-zero eigenvalues. What is the non-zero eigenvalues?
For the A matrix, I got a non-zero eigenvalue as 4.
So why are you going to find out the A value and eigenvalues? We are interested into AB and BA. This is the main fault you are doing. The eigenvalue A and B can be different.
Yeah. Sorry, sir. I will do again.
मेरी थ्योरी फेल कर दी. मैं सोच रहा था यार मैं कहाँ जाऊँ, थ्योरी फेल कर दी बच्चे ने. I was thinking कि यार थ्योरी फेल हो कैसे गई. अगर फेल हो जाती तो वो भी बढ़िया होता वैसे. I can do something better than, okay, I can do something else on your theory. Sometime that may be possible, but because I have written all these things, step by step. So I was thinking step by step, no problem. Okay, that kind of confusion may be, okay, that kind of confusion may be. Then you have created one more question. Let us consider we have two different matrices and eigenvalues are different. It means eigenvalues are different. Then you can say, but AB and B are same eigenvalue. Two matrices A and B has different eigenvalue, but AB and B are same eigenvalues. Okay, this kind of question you can also write down. So it means this is also clear, student. So by the help of this question, this is also clear that if AB and BA are same eigenvalues, but AB has eigenvalue lambda and eigenvector x, then BA has eigenvalue lambda but eigenvector bx. Yes or no? So in all the cases, the similar matrix has same eigenvalue, but eigenvector are P inverse x. That is also some problem. Yes or no? P inverse x. In this case also, it means eigenvector may be different. So maybe there are some questions in the exam they can ask about the eigenvectors. Done. Yeah. This question is clear. अभी भी क्वेश्चन कंप्लीट नहीं हुआ है. Okay. This is the level of this question. Yes. This is also absolutely, this is true. AB and BA has same eigenvalues, same characteristic values. But answer number C, A and B belongs to MNR. AB and BA has same eigenvalues. Okay. Can you say AB and BA has same minimal polynomial? Yes. Can you say same minimal polynomial? How? This similar matrix has same minimal polynomial. Similar matrix has same minimal polynomial. फंस गए यहां पर हम. AB and BA has same minimal polynomial. Yes. One more minute I am giving you. Just think about similar matrix has same minimal polynomial. अच्छा, AB equal to BA, then same minimal polynomial. Going back. अच्छा, if you take this example, A and B, AB, BA is nil port, BA is zero matrix, zero eigenvalue, lambda square is the minimal polynomial. Lambda square is a minimal polynomial. What is the minimal polynomial of AB? देखिए जरा, AB is eigenvalues 0 0 है, so lambda minus 1. Lambda minus 1. Is it possible? Lambda that is similar matrix has same minimal polynomial. No. Similar matrix has same minimal polynomial. Can you say? How can you say this is no? Can you give me two similar matrix? See, मैं आपको और बता दूं बात, पीछे आ जाते हैं और डीप में आ जाते हैं. A and B, then AB and BA has same minimal polynomial. AB and BA may be similar or may not be similar. Yes or no? May be similar, may not be similar. If similar, I am asking similar matrix has same minimal polynomial, number 1. If not similar, then AB and BA has same minimal polynomial. We have two questions in our mind. And answer is AB and BA does not have same minimal polynomial. You have to find out the answer. You have to find out such example. This is your duty. AB and BA does not have same minimal polynomial. AB and BA has same eigenvalues. AB and BA has same eigenvalues. But not same minimal polynomial. Same characteristic polynomial, but not same minimal polynomial. This is my question. Please just search over the internet, Google, everything. But I just suggest you just use your brain and solve and tell me if this is false. And sir, I have given this example. Done. क्योंकि मैं और ज्यादा समय लगा रहा. If AB and B are equal, so see, if AB and B are equal, then same matrix has same minimal polynomial. That is okay. If AB and B are not equal, yes or no? Yes or no? Even the matrix has same eigenvalues, same characteristic polynomial, but matrix is different, na? but matrix is different now. Matrix is different, yes or no? If matrix is different, then maybe the polynomial is different. The polynomial are different. डन. चलिए नेक्स्ट क्वेश्चन कराता हूं. बहुत लंबा समय ले लिया मैंने आपको क्वेश्चन में.
Sir, I think if they are invertible matrix, then we can prove them as a similar matrix, and from then we can say that they have same minimal polynomial. Am I right, sir?
मैं तुम्हें पूछता हूं पहले एक पूछो. You are saying कि if A and B are invertible, okay, then also they are similar. Yes, yes. Then AB and B are similar. That is okay. Then same characteristic polynomial. Okay. Why same minimal polynomial? Why same minimal polynomial? This is my question. Yes, बताइए. Why are you saying this? These are same eigenvalues, same minimal polynomial. Yes.
Sir, if it has same characteristic polynomial, then its roots are eigenvalues, and both matrix have same eigenvalues.
ठीक है.
And it has same eigenvalues. So algebraic multiplicity will be same.
Okay.
So then the minimal polynomial will be same.
Why? This is the problem, na? Huh? If you are saying minimal is not unique. No, minimal is unique, na?
If minimal is not unique, then it will not be similar, sir.
Minimal is unique. A minimal polynomial is not unique. Who told you? Minimal
polynomial is unique. I am saying minimal polynomial is unique, and they both matrix have same minimal polynomial. I am saying that.
Tell me one thing. You are saying कि if two matrices are similar, देखो I am giving you very well proof कि why similar matrix has same eigenvalues. ठीक है? Like A matrix has eigenvalues lambda, so this is the characteristic equation. Okay, then B is equal to P inverse AP. Then what you do? You multiply P inverse P, because this is one determinant, that is P inverse P, that is into 0. The answer is 0. So that is P inverse determinant of P, determinant of A minus lambda I, that is 0. So you can write down P determinant E minus lambda I, determinant of P inverse, that is determinant of P, that is 0. So determinant of P inverse AP minus lambda times of I, because P inverse P is identity 0, so B minus lambda is 0. Am I clear? Yes or no? So the point is, just understand my point, कि we have taken कि A and B are similar. If A is similar to B, then same eigenvalues. Yes, this is okay. A and B are similar, then same eigenvalues. The question is, if B and A are similar, so A and B have same eigenvalues, then A and B are similar. This is my question. पहले ही बताओ मुझे.
Similar matrix implies same eigenvalues, not same eigenvalues implies similar matrix.
Can you give me an example? Similar matrix has same eigenvalues. That is well-known example. But same eigenvalues are similar matrix. If you say similar matrices are similar, it means if this is diagonalizable, this is also diagonalizable. So there are so many result. Okay. एंड अभी चलो ये बात तो मेरी क्लियर हो गई. पीछे अभी मेरे से कह रहे थे आप लोग, yes this one, if A and B are non-similar matrix, AB and B are similar. If AB and yes, if AB and B are similar, same characteristic value, same characteristic polynomial, but minimal polynomial are not same. I am saying minimal polynomial are not same. You are saying same matrix, same eigenvalues. If lambda is eigenvalues, then that is also lambda eigenvalues. And I think Manoj, I think Pransu has said the same algebraic multiplicity also. Yes, same algebraic multiplicity also. See, whatever I have proved, same eigenvalues. See, say similar matrix has same eigenvalues. What does it mean by? What does it mean by? कि algebraic multiplicity also same? This is my question. Is it same? Yes or no?
Yes, sir.
Pakka?
Yes, sir.
Yes?
Yes, sir.
Okay. So if two matrices are different, like you are saying we have a matrix A and A is different, AB and B are different matrix. These has same characteristic polynomial like lambda minus 1 ka whole square lambda minus 2. This is lambda minus 1 ka whole square lambda minus 2. It may be that you can find out the answer. It may be that this is annihilated by lambda minus 1 and lambda minus 2, but this is only annihilated by this polynomial. Okay, this is the minimal of this, this is the minimal of this. I can give you example, but I am not giving right now. Just search and tell me कि similar matrix नहीं कह रहा हूँ, AB and BA we have two matrix, but both does not have same minimal polynomial. एक बार जरा चेक कर लो कि होता है नहीं होता है. ठीक है, अगर नहीं होता है तो मुझे प्रूफ दे दो कि सर इसका मिनिमल पॉलिनोमियल, both minimal polynomial are same. If you can give me the proof, ठीक है. If you give me the proof, then I will be very happy. Otherwise, give me example. Because directly नहीं कहेंगे क्वेश्चन. इस क्वेश्चन पर लगभग we have 10 more questions based on this question. Once you do this, then all question will be clear. That's why I am not giving the solution. Then we will discuss after 1 or 2 class. No problem. What is the problem? No problem. Then next problem पे चलते हैं अपनी. अच्छा, एक क्वेश्चन और बताना मुझे. मैं आपको एक क्वेश्चन पूछ रहा हूं. AB is diagonalizable if and only B is diagonalizable. AB is diagonalizable if and only B is diagonalizable. This is also one of the question. If you can solve, please tell me. Otherwise, I will discuss with you. चलिए. Okay. Let S is a set of 5 cross 5 matrix such that summation AI is a I is equal to 1 to 5 is 1 for all j, and AI is 0 or 1 for all I. So what is the cardinality of S? What is the cardinality of S? 120. Pakka. How?
Yes, sir. 5 factorial, sir.
Factorial. Achha, what is the meaning of this problem? What do you mean by this line? What do you mean by this line?
Sum of the row will be 1.
Sum of the row or column?
Row or
Please check. This is the row or column? I think column sum. Column sum or row sum? What is this? एक बार check कर लें. A1J. Okay. A1J मैं भी check कर लेता हूँ. A2J, A3J, A4J, A5J is 1. Okay, I will check. J is equal to 1, A11, A21, A31, A41, A5. What is this? This is row sum or column sum?
Column sum.
So you have to understand. Okay, yes, this is column sum. So column sum is 1. And all the entries are either 0 or 1. So we have like column sum is 1. So column sum is 1, then it must have 5 possibilities. Yes or no? Yes or no? Am I clear? So what about second column? This also has 5 possibilities or 4 possibility? Yes?
There are five possibilities, sir.
5 possibility.
Because there is no foundation for row, sir.
Yes. So this is no foundation on row. So this is also 5 possibility. This is also 5 possibility. This is also 5 possibility. Can I write down answer is 5 raised to power 5?
Yes, sir.
Yes or no? So your answer is wrong. Yeah? So don't be worried about I am saying your answer is wrong. Don't be frustrated. I am just giving you some of the most important questions, the most important tricks, which is like at the end of the sessions. Okay, मैं थोड़ा सा आपको दे रहा हूँ कुछ questions. I have so many questions, but बस जितने क्वेश्चन करा दूंगा सफिशिएंट है. ठीक है, सोच समझ के मैंने आपको क्वेश्चन निकाले हैं आपके लिए, so that you can do better in your exam. Okay, yes. If I do same problem as, but I am not happy कि student are not understanding. Now they are only 10 student. Why? Student must be constant. भाई IIT exam देने जा रहे हो, not a you are not doing a like some you are not playing a game. Just try to understand. मैंने जो प्रॉब्लम्स आपको दी हैं, बनाई हैं कुछ प्रॉब्लम्स, कुछ मैंने कहीं से ली हैं. These are not as much as easy to form or like create some problems. Yes, this one. If I say AI is 0 for all, a 0 1 for all I and J. So this is called row sum. So what is the cardinality of S?
5 power 5, sir.
Same 5 raised to power 5. Now then there is no restriction on column. Okay. Yes or no? Done?
Yes, sir.
Okay. Now one more question. What is the meaning? This is row sum is also 1. Sorry, column sum 1. And row sum also 1. What is the answer?
5 factorial, sir.
The answer is 5 factorial. Why? Because you are taking like 5 possibilities. So you cannot take here 1. It means this possibilities has cancelled. You have 4 possibilities. So you have taken 1 entries here, 1 entries here. Then you have only 3 possibilities, 2 possibilities, 1 possibility. The answer is 5 factorial. Yes or no? So it means row sum 1, 5 raised to power 5. Column sum 1, 5 raised to power 5. And row sum and column sum both are 1. That is 5 raised to power, not 5 factorial. Yes or no? अच्छा मुझे एक चीज और बताओ, यस इन दिस क्वेश्चन हाउ मच टाइम वी हैव? 55 56, ओके वी विल टेक 5 more minute class. अच्छा रो सम इज 1, we can have singular as well as non-singular matrix, yes or no? Row sum is 1, we can have singular or non-singular matrix both, है ना? Yes or no? Yes or no? If row sum is 1, you can have so many, like row sum is 1, so you have this kind of matrix, all these are 0, yes or no? So you can have which matrix? Singular also, non-singular also. Column sum is 1, you can have singular as well as non-singular matrix with entry 0 or 1, yes or no? With certain condition. See, we have 4-5 category questions I am giving you clearly. Aij 5 cross 5, Aij 0 or 1. We have 2 raised to power 25 matrix, yes or no? Because there is no condition how many matrix of Aij where entry 0 1. So each entry has 2 possibilities and we have 25 entries, yes or no? So we have 2 raised to power 25 matrix. When you take A 5 cross 5, Aij 0 1, row sum 1, you have 5 raised to power 5 matrix. You are taking Aij 5 cross 5, Aij 0 1, column sum is 1, you have 5 raised to 5 matrix, yes or no? Just understand, in this matrix we have invertible as well as non-invertible, yes or no? We can have invertible, 0, non-singular, singular, all these things. In this also we have singular, non-singular also. In this also we have non-singular, singular. But the question is, when you have this matrix Aij is 0 and 1, row sum 1, column sum 1. This is 5 factorial matrix. This is only non-singular. Can I say yes or no? Yes or no? Why? कोई बताएगा क्यों ये non?
Yes, sir.
Why this is
Sir,
non?
it has full rank, sir.
Nee, why this is has full rank? Why this has full rank? Actually, if you write down here like this one, so you have to make the row sum is 1, column sum is 1. So you have to take this next row as independent of this. Otherwise, 2 rows will be same, column sum, row sum will be 2. You have to take these 2 as linearly independent row. Otherwise, row sum will be 2. Yeah, row sum 2, yeah, column sum 2. So column sum will be 2. Yes or no? So you have to take linearly independent. So you have to take like this. Yes or no? So if you want to make the row sum or column sum this, you cannot take this entry and the next row. Can you take? No. Otherwise column sum is 2. So each column and row sum, if you shuffling all these things, then you have to make all the row as linearly independent. The rank is full. Is it clear to all of you? No, I am not saying identity matrix. You can have so many matrix. You can have so many matrix like 1 0 0 0 0 1 0 0 0 0, and that is 0 0 0 1 0 0 0 1 0 0 0 0 0 0 1. This is not identity, but this.
Sir, can we apply permutation formula?
Yes, actually this matrix is nothing but, this set of matrix is called permutation matrix. This is called permutation matrix. पता है permutation matrix की definition क्या है? Permutation matrix is a matrix in which entries are from 0 and 1. Entries are from 0 and 1. Row sum is 1. No. Permutation matrix definition is the entries are from 0 1 and matrix is non-singular such that each column or row contain exactly 1 1, otherwise 0. Am I clear? Actually this definition and this definition both are same, both are equivalent definitions. Both are equivalent definition. What I am saying, just try to understand. I am saying a permutation matrix is a matrix, sorry, क्या हो गया ये, जो भी है. A permutation matrix is a matrix in which all the entries are either 0 or 1. Number 1. Matrix is non-singular. Okay. Each row or column has exactly one entry as 1, otherwise 0. So you will form this matrix only. And permutation matrix is always non-singular. And whenever you find this kind of things, this is also non-singular. Is it clear? So this is nothing but a permutation matrix. And please note down this kind of matrix, this kind of matrix, this kind of matrix. The non-zero matrix has always determinate P equal to plus minus 1. Why? Because whenever you have linearly independent row, this kind of things, so you can make this matrix by swapping of row as identity matrix. So what do you do? When you swap the matrix, swap the row, you will multiply by minus 1. So if you multiply by minus 1 even times, then matrix is identity, determinant is 1, otherwise determinant is minus 1. This question is clear? Yes or no? And second, one of the most important question, orthogonal matrix. Tell me, orthogonal matrix always has determinant plus minus 1. So can I say every orthogonal matrix is a permutation matrix? Every orthogonal matrix is a permutation. I will take 2-3 minutes also, because this is the last topic, last question. Like this is something very good question, I cannot skip. So just wait for 2-3 minutes also. So the next question is, every orthogonal matrix is permutation matrix?
No, sir.
Not permutation. Why? Because we have a lot of example. We have cos theta, sin theta, minus sin theta, cos theta. All these are orthogonal of 2 cross 2 orthogonal matrix. Okay, and but this is not permutation because all the entries are not 0, 1 for every theta. Yes or no? Is it clear? This rotation matrix is always orthogonal for all theta, but all theta, when you take some matrix, there are uncountable number of matrices which having entries except 0, 1. It means matrices are not permutation. But can you say that every permutation matrix is orthogonal? See, all these rows are linearly independent. These are the standard basis. Whenever you have, these are the standard basis. Yes or no? These are the standard basis R1, R2, R3, R4, R5. These are the number of linearly combinations. Yes. So just 2-3 minutes. I am just finishing this topic. So this permutation matrix has row as a standard basis, and there are a lot of combination of the standard basis which will create a permutation matrix. Yes or no? मेरी बात समझ में आ रही है नहीं आ रही है? Yes, you are getting my point. So it means if these row are independent, it means these vector are linearly independent, and linear independent vector has dot product, because when you take this orthogonal matrix, if you multiply this and this transpose, it means whatever this row is there, this row is there. So these are linearly dependent, and this row is linearly dependent to अपने आप से तो linearly dependent हो जाएगी. It means the answer is 1, and when you take otherwise multiply, the answer is 0. Yes or no? So these are linear dependent, linearly independent eigenvector, linear independent standard basis has inner product 0. Inner product 0. It means if you multiply this into this row as this, if you multiply this, take P matrix and P transpose find out, and P transpose is always identity. It means every orthogonal matrix need not to be permutation matrix, but every permutation matrix is an orthogonal matrix. This was the last question. I hope you understand my point. I think you understand my efforts also, ki what I have taught you today, and these are the wonderful questions in my point of view. I don't know what your point of view is saying, but in my point of view, these are the very good question, high level question of the IIT exam. Okay, are you agree? अगर ऐसे क्वेश्चन आ गए ना एग्जाम में, तुम कर जाओगे, जो बच्चा पढ़ रहा है इस टाइप से कर जाएगा. 95% student will not touch this kind of questions, but this kind of question really create a stamina, a positiveness. I know this kind of things. This will create a great impact. Okay, so thank you very much. You have attended the full class. The student who have attended the full class, this the most important series. Thank you very much.